Hello, my name is David Curran and I'm a machine learning engineer. And what I'm going to show you today in a quick talk is how to quickly improve your machine learning and your data sets so that you can get higher accuracy and help your customers get their answers quicker. So how am I going to do that? Well, the code I'm going to use is up here on GitHub. So you can play along at home. github.com, cave dave, data cleanup. And here I have it running in a Jupyter notebook. So what is machine learning? Why would you want to clean up a data set? What's going on here? Here, I'm going to guide you through a data set of a shop that has a chatbot for bunnies. So in any machine learning task, you've got to get some data. Say this could be images. You've got pictures of cats and dogs. You want to see what the difference is. Or you've got pictures of number plates or not number plates. You want to find the ones with number plates. Or this could be text, something like email or spam, and you want to see which one's which, and you want to get a computer to tell in future, right, I know what the email is, I know what the spam is, I know what the person's asking me to do. So in this case with the bunnies, it could be trying to buy a bunny, or it could be trying to make sure the bunny's healthy, or some sort of question like that, and you want to see what is the person asking about. So today, in the process to make a classifier that you can use to help your customers, you're going to have to get data, you're going to have to label the data, then you're going to have to go and fix the labels. Then there's some stuff with classification where you find out, what you thought was the classification is wrong, and there's a bit of messing around there. And then there's the stuff that you hear all about, which is the finding new algorithms, building new processes, building new models, all this sort of stuff. And that's great, that's wonderful, that has to be done. But that is only one part of the machine learning process. Unless you've got good data, you're not going to get good answers out. Garbage in, garbage out. So bear in mind that while deep learning and all these algorithms are really great and really important, cleaning up data is a much easier, quicker win. And I'm going to show you today just a quick couple of steps, no matter what your machine learning task is, be it text or images or even audio, that will really help you quickly clean up your data. Okay, so this is going to be playing along at home. So if you want, grab that GitHub there and we can start playing with this. So that's Cave Dave data cleanup. Okay. So obviously you load your libraries at the start. There's nothing particularly surprising here. Scikit-learn is a good, handy machine learning library. Most people who use Python have known this. Pandas and NumPy are used for manipulating the data around. And other than that, it's fairly standard stuff. Okay, so I've done a list of tasks here. So in future, you'll have a list of 12, 13 steps to go through. But if you go through these steps, you'll probably clean up your data pretty well. So you can tick them off as you go along. Load libraries, we've done. Next up, load the data. So loading data is standard in Python. Just load up your CSV. And, oh, I haven't actually loaded the libraries. That's a mistake I made. Let me load my libraries. Now you can tell it's live because I made a mistake. So I think it's always worthwhile to see what the data looks like. Are the baby rabbits certified? Rabbit certification. We could look at the tail maybe as well if you want. I'm not going through today how all these got initially classified. I'll save that for another talk. But you have an online shop like on Facebook where people are selling flowers or whatever, and we're imagining here that it's a rabbit selling shop. And at the end of it, we've got examples of how people have asked to buy a rabbit. Have you any rabbits to buy, any rabbits to sell, that sort of thing. That's sometimes called the ground truth. You've got a question and you've got a label. So thing people want to do, and you've said, all right, what they mean to say is purchase a rabbit, or what they would say if it was just in a very defined way. Okay, so what's next? We've read in the data, we've loaded our libraries, and now we're going to do a test. So this is a common issue in machine learning called a k-fold test, and this loses a lot of people. So if you get this idea, you'll understand the rest of the talk. So I think it's worth spending a minute on. If you imagine where you have your training data, your ground truth, and you randomized it, you shook it all up, shuffled it around, and you trained on 9/10 of that data. So you have 9/10 of all the questions where someone asked to purchase a rabbit, and roughly 9/10 of the questions where someone asked about the rabbit's family, and roughly 9/10 of all the different topics that people were talking about. And then you trained up on that 9/10, and the 1/10 that you'd left over, that you'd put aside, this we call the test fold here, you then see if you would get those right. So you've trained up on 9/10, you have a classifier built on 9/10, and you send in a question it hasn't seen from the training data, but not this particular training data, that says, what do I do if my rabbit is sick? If it gets rabbit vet, it's correct. 1, you add up all those, and you get an accuracy. Now, this is where it gets slightly confusing. So that's simple enough. You shuffle everything, you train up on 9 different buckets, you test on the 1/10 that's left over, and you have an accuracy. We got 70% of those right, something like that. You do that for each of the buckets. Each of the buckets become a test bucket at some point, and then you've got a view of all of the training data that's in your ground truth that said, if you didn't know about this, would you have gotten it correct? So here, I shuffle the data and I make folds. In this case, I use 5 folds. 10 is probably more normal, but it's a small enough trained data set. So now, classifier here. This is what happens in most machine learning talks, where they talk about the classifier and a new kind of classifier and a particular kind of wiggle you do. And that's the papers that are written, and that's the academic side of it. And that's really important, but also it's not nearly as important as people pretend it is. Cleaning up your data gets you a lot more bang for your buck. Okay, so here it's a particular text classifier where I turn all the words in our ground truth into what's called a vector, like an array, where is the word aardvark there, is the word and there, is the word all the way up to zebra, whatever the last word is. And then of a particular classifier here, it's a type of SVM. You could use something simple like a naive Bayes, but it doesn't really matter. This is just a pipeline, quite a simple one. And you'll have a pipeline in any machine learning task where you turn the training data into something the computer can understand and make a classification on. And usually that's in some way a series of bits. You know, this is here, this is not here, something like that. But that's not what this talk is here. This is about the data. Okay, so now here we're going to run that k-fold test, the one in this picture here, where we're training on a lot, testing on one, and we're doing it again, but on a different test bucket. Okay, so that there is done a training test, and it's given us an accuracy of 67%, which is not great. So usually with a chatbot like this would be helping people on Facebook, on a rabbit seller, a shop on Facebook, answer their questions. Usually you want to be about 80% accurate before you go live. That means in any individual question, you'll get it right 80% of the time. Then people will realize maybe, in that 20% where you're wrong, people might realize you've made a mistake. They might rephrase it and get to the right answer. Or maybe they're asking a really hard question that once you won't get right. And that's sort of a launch figure, 80% accurate. And as you get more and more data, as the thing is live and you look at the logs and you get new data, that will go up, of course, but it'll never get to 100%. One thing to realize with machine learning is you're never fully right. And you have to sort of get your head around the idea of you just trying to improve and get better rather than go for perfection all the time. Okay, so I'm going to save this data to a CSV. One of the things is 67%, 68% accuracy. It's not that great, but if you can show the boss 68% accuracy when we started this process, I cleaned up the data, we're now at 72, 73% accuracy, he can see at least you're going in the right direction. So it's an important thing with machine learning is to have a metric, make sure it's a realistic metric, and then go try and improve things. And then be able to show the boss as well, look, things are getting better. Maybe they're not good enough, but at least we're moving in the right direction. And they can understand that, you're moving in the right direction here. Okay, so now the guts of the talk here is to find errors. What are we doing wrong? And this here is for a text data set about a shop selling bunnies. But in any machine learning task you had, this could be something similar. This could be, images or anything else. And these sort of processes are what you go for. So three kinds of errors, actually four in this case: duplicates, an obvious enough one. It's just you don't want to have the same question in twice or the same picture in twice. Confident and wrong, first thing you look for really. The second confidence, as in the machine learning algorithm's second guess, was really high confidence, and the third one is the guess was really low confidence. So when a machine learning algorithm makes a classification, I would like to buy a bunny, please. If that was classified 99% certain, really high confidence, that is an example of bringing a bunny to a vet. There's something wrong there. It's high confidence as well. If the question was, if the second confidence, so it comes back my first guess and how confident I am, my second guess and how confident I am. If the second confidence was really high, 80% certain that that's bring a bunny to a vet, something wrong there. And then if the general confidence level, I think it's bringing a bunny to a vet, but I'm 2% confident, there's something up there. So by looking at these three areas, you can really improve the accuracy of your data set. And this happens in even sort of the big popular data sets that are used by everybody. When someone goes back into them and takes the time to look for these sorts of errors, they tend to find serious issues, and that improves things for everybody. So what does that actually look like? So let me make this a bit bigger maybe. The question in the training data was any rabbits to sell. In the ground truth, we've said that's a purchase rabbit intent. That seems realistic. Our system guessed it was purchase rabbit. Great, okay, that's correct. Has the kit gone to the vet? We've told in our training data that that's rabbit health. We've guessed it's rabbit health in our K-fold test. Great. Okay, so now we're going to go look for these kinds of errors, and keep in mind your kind of data. What data do you have? Is it pictures? Is it text? Is it sound? And what would this look like in your data? So here I've looked for duplicates. Do we have any? Nope. Now the next one, high confidence wrong. So this is a dog that's pretending it's a bunny. So this here is a piece of text that says, if I've got really high confidence, over 95%, and I got it wrong, tell me those ones. Okay, so here we have, has the rabbit been fed? The ground truth says rabbit food. We guessed rabbit health. Maybe we need to look at our rabbit health because there's something in there that is wrong. Rabbit certification. What's this question? Has the rabbit been certified, and how do I get the certification? No, that seems correct. But if you look through these in a real data set, you'll see examples where you've just mislabeled. Maybe it was early on. Maybe it was when you're just starting to label the data. Maybe when you didn't understand things correctly. Maybe someone just made a mistake. People make mistakes. That happens. And a good way to find them is where the ground truth says one label, your prediction system with your K-fold test says a different label. Maybe the prediction system is right. A lot of the time it is. In my experience, just this one check, you find where your ground truth has the wrong label in it. You put in the label where the classifier was correct, the K-fold classifier, and then you've improved things by about 2%. And that's kind of what you get out of like the latest, greatest, best algorithm. So that one check alone is as good as an awful lot of the sort of really complicated stuff you could be doing. Okay, let's go back to here we are. So first check, find things where my classification was high confidence and different to the ground truth, and maybe your classification was correct. Okay. Second thing then is if the second confidence is very high, let's change that to 30%, I think is what reasonable. So the confidence 2 that came back was quite high. And a lot of the times what's happened here is someone's asked 2 questions. So things like can I cancel the credit card and get a new one? It's 2 things are happening at the same time. How you deal with that is slightly complicated. Sometimes you split up the question because the person should have asked one question. A lot of the time, particularly with banks and stuff, you have to change how the bank sees or an insurance company sees the problem into how the customer sees the problem. It's a sign that what the bank or the insurance company sees as two questions in anyone normal's brain is one question, and you have to change the intents to take that into account. To take into account that cancelling a credit card and getting a new one to a bank is two things, but to any normal person it's one thing. So look for cases where the second confidence that comes back from your classifier is quite high. A lot of the time it's two questions. A big one that happens here is complaints. People tend to complain about two things at once. The old joke about the food was terrible and the portions were small. That's what happens. So what you should look for a lot of the time with the second confidence high is it actually two questions? Is it from a complaint? What's happening? Because sometimes the second confidence high is kind of correct. It's asking two different questions, and we need to figure out how we can make that either into one intent or to change our model entirely. So it's just something to keep an eye on. So if the second confidence high, have a look through, and in some of those cases, the question will be ambiguous or how you've made your classifications ambiguous. Okay. So the last one, and it's quite a simple one, this is look for where your confidence is really low. The system comes back at really low confidence, and why is that happening? And a lot of the time it's because it's nonsense. Frequently with text issues, what's happened is you've gotten something wrong with your encoding. So somehow you've not used UTF-8, you've made a mistake, something like this, and it's garbled the input. It's turned it into just, syntax effectively. It just looks like it's messed up, and that's because you've made a mistake there. So if you look for low confidence answers, you can find things. And sometimes it's just, someone writes in the wrong language. That's in Irish there. Someone writes something that's just nonsense. These things happen, and low confidence is a place to find these. So in effect, that's a bad example you've put into your ground truth. Purple monkey dishwasher is not an example of purchase rabbit. It shouldn't be in there. It's going to confuse matters. And if you look for these low confidence values, you can find that and remove it. Okay. And then in the end, we write all these to a HTML doc to make it easy to show your boss, look, this is what I've done. These are the errors I've found. These things I've fixed. Okay, and we have a bit of time, so I'm going to go through a few more things to look for. But if you remember that just for today, if you get a data set, run a K-fold test with a reasonable classifier, it doesn't have to be the best classifier in the world, and look for high confidence wrong. Second returned answer has high confidence and really low confidence. Combine those together and you're talking usually about 5% of a 5% accuracy improvement, which is a big deal. If you can find that sort of messed up data, it really helps an awful lot. Okay, so finding bad intents here. What is we doing here? So some of your intents. So purchase rabbit is an intent. Vet is rabbit vet is an intent. Rabbit parents is an intent. Some of these will have low accuracy in your K-fold test, but that's because you don't have many examples. You need in a chatbot data set 7, 10, maybe even 20 before you get really high accuracy of, yes, next time I see a new way someone asks to purchase a rabbit, I'm going to know what they mean. So here's just a bit of code to show the intents that are low accuracy. So you're probably talking, if we want things to be 80%, any intent that has accuracy below 75%, 70%, you want to have a look at and see why is that going wrong. And you'll end up having, it's easy enough to produce a graph like this, just a scatter plot, where if you've got a lot of training examples and your accuracy is low, there's something wrong. So anything in here where you've got enough examples and your accuracy is low, go look at that and see why it's going wrong. Go look at that intent. If you don't have many examples and you're going wrong, that's kind of to be expected. And if you've a load of examples and you're doing really well, really high accuracy, again, that's to be expected. Confusion matrices is an easy thing that Python allows you to look to see if two particular intents are being mixed up. So you can imagine a situation where two things are similar. I want to cancel a credit card and I want to cancel a debit card, and people just come along and say, "Can I cancel my card?" They're going to get confused, and looking at a confusion matrix can show you these things. So let me see. Can I show you the confusion matrix? That's just sent into a CSV file. You can turn it into a picture. It'll just jump out. Two intents are being confused. Have a read through both intents. Figure out why. Maybe you can merge them. Maybe you can separate them. Maybe there's like a parent intent, cancel card. And then based on cancel card, you have to say, oh, do you mean credit card or debit card? Or these sort of things you can do. Okay, what else we got? So usually the fastest way to do these things is, and you won't always be lucky enough to have this, is if you can label up 500 questions, 500 images, something like that yourself, run this process to improve those 500 classifiers, improve the accuracy of that data set to remove any problems you have in it, and then use that to sort of bootstrap to label the next 500 questions or images or whatever it is you have. An example you have, that the advantage of that then is, instead of you having to label another 500 by hand, what you can do is you can, in a batch mode, go through those new questions that the system has labeled, and you can say, was the system correct? So you can ask yourself the question over and over again, is this purchase rabbit? Is this purchase rabbit? Is this purchase rabbit? Rather than having to say, which one of the possible intentions is this question? You can select all the purchase rabbit questions and you can rapidly go through them and say, is it this? Is it this? Is it this? You're asking yourself one question over and over again. It's much faster. To give you an idea of how much faster it is, they used to say it took 15 minutes to label a question from beginning to end. And with a process like this, you're talking well under 5. So batch processing things just really speed you up an awful lot. Here I am running a quick classification and outputting the labeled data. And so what I mean here is you say, select all the predicted examples of rabbit certification and say, is this? Does the rabbit have a certificate? Yes, it is. What search does the rabbit have? Yes, it's rabbit search. You can very quickly ask yourself the question, is it this? Is it this? Is it this? And you rapidly get much more data classified. So you kind of bootstrap your data where you build a good enough classifier to go classify all the rest of your data. And then you go through the rest of the data, just asking yourself the question, was the classification correct? You have to be careful. You don't want to get too fooled. It still does need your brain to decide whether something was correct. But once you're careful like that, you can just go a hell of a lot faster. Okay, so just at the end of this data, there's a few more things around showing your boss what you've done. So it's very easy, particularly for programmers, where we sort of disappear, go off, make everything brilliant, and then we don't really tell the boss enough what we've done, why it was good, what steps we did, and he can see, why, here's a graph, we were here, we're now here, we're going in the right direction. So dashboards and stuff are good for this, but again, I think people sort of overemphasize dashboards. A nice graph once or twice a week where you say, realistically, a nice graph on Friday to say, right, our accuracy was here, it's now here, and these are the steps I did, just makes your boss's life easier. So she'll be happy with you. Okay, so let's go sharing screen again. There we are. So just a simple bar plot of here's how we're doing, and if you can show the boss that, actually I think I missed a page. Yeah, if you can show that, oh look, we're getting better, it just makes everyone happier. That picture, in that case we're getting worse, but you can see how we've saved our accuracy, we've improved things, we save our accuracy again, and you can show the boss at the end of the week, look, things are getting better. It's a small, simple thing, but you'd be surprised how many people don't do it. This here is more in the weeds of how you go around changing language, but that's probably go around processing language. That's probably for another talk. Okay, so thank you very much for your time. What I'd like you to get out of this talk is basically, we have data in your building, in your office. There's some data there that a machine can classify and do a really good job of predicting things on. Go find it. It's there. How to label it up? It's easy enough. You can label it up. I'll give another talk again about how to label it quickly and speed things up. Then fix these labels, because you'll make mistakes, and that's normal. And that's what this talk is. Look for those three things: high accurate, wrong. Second prediction has high confidence, and just really low confidence because it's probably nonsense. Once you have those 3 steps done and you've gone through it, your data set's going to be in a pretty good condition. That's the sort of thing you can go and show to the boss and say, look, we have this data. We can make good classifications on it. We have the data now cleaned up in a really good way. Let's go make a image classifier that will tell you if your windscreen's chipped, or a chatbot that will help customers get a new card, or some simple task like that. You'll have the data cleaned up in a way that makes that task really easy. So the talk was just to encourage you to look at that data and give you some idea of how to start analyzing it, finding faults, and cleaning it up. I'm available if you on the GitHub there. If you ask me any questions or anything, I'll answer them straight away. And hopefully this will help. Thank you very much.